Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 5.1, Roots of Cubics and Quartics. To find the roots of quartic and cubics, you either break down the equation by solving, or you can create the equations using the roots. The roots are denoted by Greek letters alpha, beta, gamma, and delta. As I have taught before, I recall there was once, I think chapter 2, I've done something with roots because there are some quartic complex roots that are kind of interesting to talk about. For here, back then, you might be confused as to how, because we're limited to only I and minus I for some of the complex roots. But as you know, there are a lot more. There are complex roots rather than just plain imaginary roots. So this will be the only window of opportunity for us to take care of those kinds of solutions. But before we talk about this, we need to kind of understand how it works beforehand, so that's what I'm going to do in this video. Let's start with a cubic. A general cubic formula is ax cubed plus bx squared plus cx plus d. And in order to find their coefficients, there are some equations that you need to actually learn. So first of all, the relation of a itself divided by a, I'll show you why I wrote this later on. It's just straight up 1. For b, we have minus b on a is equal to the alpha plus beta plus gamma. So alpha, beta, and gamma are the three roots respectively. As I've said before, highest power is equal to the number of roots, and that holds true here, which is good. The third one, c on a, is equal to alpha beta plus alpha gamma plus beta gamma with that pattern. And so finally we have minus d on a, which equals to, have a guess, from the pattern shown above, alpha beta gamma turns into alpha beta plus alpha gamma plus beta gamma. So essentially it's individual roots, then pairs of roots, and finally triplets of roots, which the only option is alpha beta gamma. So that's all of the possible roots combinations. And that will make alpha A, B, C, and D respectively. So the point of A on A, well, first of all, you can see the pattern why the over A is there. The issue with this whole thing is that this A technically have no real meaning. So if I want to multiply the whole equation by 7, it can be absorbed into A, and everything would kind of be the same, if you see what it means, because technically the root, if you remember, is the point at which it crosses the x-axis, and by multiplying the whole thing by an arbitrary value, these points are stationary, they do not change, and so the value of A, or the coefficient, doesn't really change the root at all, other than the fact that it would stretch the whole thing by a certain shape like this. This is just poor drawing. You know what I mean. And one thing I want you to take note of is the pattern here. These root terms are important for your understanding of higher powers. So over here we have, if we convert these terms into the number of terms, we have one term here, we have three terms here, we have three terms here, and we have one term here. Wait a second, this looks familiar, doesn't it? 1, 3, 3, and 1. If you remember your Pascal triangle, this is the power 3 binomial expansion coefficient. Power 3 binomial expansion coefficient. Turns out these things have a relation with the Pascal triangle. I'm going to show you that again for the quartic. Do try to do it parallel me or do it ahead of me for the quartics, and check your answer if you can kind of guess the final relation. Once again, we have general form of a quartic. It looks sort of similar to the cubic. It works almost the same, except the fourth root is now delta. To note about this, if you want to attempt to do the steps that I've done in the cubics, go ahead. You can pause the video, but I am going to show you right now. So first of all, again, A on A equals to just 1, then minus B on A is equal to, oh, actually, by the way, note the negative alternating pattern. That's due to odd powers. So odd powers gives you a actually no, the, how should I call it, when you have an odd number of roots multiplied together, you have a negative. So you've got so you've got alpha plus beta plus gamma plus delta. So this is one single root, which is odd number of roots multiplied together per term. Then you've got C on A, which has 2 alpha beta alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. That's 6 terms. Then we've got D on A negative is alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. So that's 4 terms. And finally we have E on A. That's positive because it's even number of roots multiplying together gives us alpha beta gamma delta. So I've got all these sorted. Now the pattern is 1 root, 4 roots, 6, 4, 1. Hypothesis holds true. Pascal triangle, binomial expansion coefficient of power 4, and everything works. And these are the patterns that you need to know of, you need to remember in order to do some of the harder equations. So I'm gonna make some questions for you to do later on. With you will need to use some given roots to formulate a coefficient equation. So I'm gonna make you do that. So for tips, do not forget the negative signs. because that would change the results drastically. Also, check the binomial coefficients pattern, because a lot of times when people do Quartics, they forget that there are 6 terms for the term C, and that would you'd not get a good number as your results, which would looks a bit awkward. There, I set the following questions for you to do. Question 2, use your brain. The question mark is workable, and you basically can tell straight up from the roots. So I'm gonna let you have a think. I'll give you 5 seconds before I show you the answer as usual, and I'll show you the answer in 5, 4, 3, 2, 1. So yeah, there we go. We have the answers shown right here. And note that the complex version have its conjugate as its question mark term. So if you forgot, do go back to the complex section to get a refresher. But yeah, basically this is it. It's not that difficult. Most of the time they'll give you the equation along with 2 or just 1 root, and you need to kind of work out the rest of the roots. And then we will do something called the transformation of roots, which I will talk about in the next video. For now, thanks for watching. I hope you've learned something. If you have any questions, let me know in the comment section below, and I will help you as soon as I can. For now, thanks for watching, and I will see you on my next one.